In this video, we will be seeing about the clustering in data analytics. In clustering, we will be seeing about the algorithm which is more important, that is k-means algorithm. Let's begin with a quick thought. How many of you have watched Netflix or shopped on Amazon recently? We have noticed that our recommendations are different from our friends. The recommendations are not same for everyone. It will be different from one person to another. This is the clustering in action. The system groups our user based on their behavior. Keep in mind as we move to the next slide. Okay, here the session objective is, by end of this session you will be able to do three things. First one is understand the k-means clustering algorithm and apply it real world problems like recommendation system and customer segmentation, and evaluate clustering result using proper technique. So think of today's lecture as a journey. We'll move from a messy problem to a clear solution. Okay, what we have empathized here is they have massive amount of customer data, but finding the right customer to target is messy and time consuming. This is exactly where clustering shows its power. Okay, now let's step into the shoes of an e-commerce company. Okay, e-commerce company is struggling with customer target. In defined part, the problem we have seen what is the problem. Here we are going to define the problem. The problem is nothing but business today faces data overloaded. Too much informations are there, but no clear labels are available. So the real challenge is, how do we automatically group unlabeled data into a meaningful way? That is where the clustering comes in. Among many methods, we will focus on k-means because it's both simple and powerful. Okay. Next, we will see about the ideate. Ideate is nothing but the possible approaches, how we can approach or solve the problem. Now, imagine the possible approaches. Manual grouping is one of the possibility, but it is impossible when the data are large in amount. Next is rule-based segmentation. Too rigid and inaccurate. Okay, machine learning clustering is data driven and scalable, and among methods like hierarchical, dbscan and k-means, today we will choose k-means algorithm. Next we will see about the prototype of the k-means algorithm, which we have taken as k-means algorithm. Let's break down how k-means works step by step. First, choose k. We have to choose k. K is nothing but the point where the clustering is about to happen. Pick initial centroid. First we have to choose the number of clusters, which is nothing but k. Next, pick the initial centroid. Okay, and we have to assign data points to the nearest centroid and again recalculate the centroid and repeat this until a stabilized clustering is formed. It is simple, but surprisingly it is more powerful in practice. Okay, next we will see about the vertical depth. Here we will be seeing about the t-shape. In that we will see about the vertical depth, which is k-means requires numerical features as input. Okay, it is usually uses Euclidean distance to measure the closeness. Euclidean distance is used to measure the closeness between the 2 points. Consider here we have one point and here we have another point. To measure the distance between these 2 points, we will be using the Euclidean distance. Okay. Next, the complexity is order of n into k into I, where here I is the number of iterations. Iterations is denoted as I, but it is not perfect. It's sensitive to outliers and requires you to know k in advance. This k value, that is the centroid k, means this value should be known in advance. Enhancement like k-means plus plus and mini batch k-means help to address this issues. It is the advanced algorithm of k-means algorithm. Okay, next we will see about the Horizontal breadth, that is application, real world application where we are using the k-means algorithm. Now let's widen our lens. Clustering is not just for marketing. It is used in biology for gene clustering, in social networks for community detection, and in cyber security for anomaly detection, and even in astronomy, this k-means algorithm is used. Okay, wherever you have data without labels, clustering can help to make it out. Next, we will see about the activity related to this clustering. Okay, let's make this interactive. Imagine each of you is a customer data point. Okay, imagine each of you is a customer data point. Now you have to group yourself based on the attributes like spending level or product interest. Few have interest on one product and others will be having interest on some other product. So based on your interest, you or attributes like spending level, you can cluster into yourself. Was that easy to do manually? Think of there are 100 students in a class. I'm asking you to cluster among yourself based on these two criteria. It is possible for you all to discuss among yourself regarding the spending level or product interest, and you have to cluster among yourself. Is that possible to do manually? Probably it is not possible. This comparison shows exactly why we need an automated approach like k-means algorithm. Next, here is a case study. Back to our e-commerce case study. K-means group user into three category. First category, the users will get a product in the basis of bargain hunter. They will be bargaining for the price. Okay. In cluster 2, there will be a premium buyers, and in cluster 3, there will be a regular subscriber. So we can cluster this based on the three categories. Okay, with this targeted marketing, sales increased by 25%. That is the business impact of clustering. By clustering these three group of people or customers into few small clusters, the result was there was increase in 25% of sales. This is the power of clustering. Okay. Next we will see about Next we will see about the given mind map. Here is a quick mind map. Notice the flow from defining the problem to applying k-means to see the real world application. This will help us to capture the big picture. Okay. Next is reflection and peer sharing. Now let's reflect. Think about our own college students' data, attendance, activity or interest. How would you apply k-means to group students? Okay, you think among yourself and you get the answer. This exercise will help you connect theory with your own context. Next we will be seeing about the quiz. Here are 4 quiz. First one is k-means is supervised or unsupervised. K-means is unsupervised. Okay, what does k represent? It represents the number of clusters. Okay, which company uses clustering for recommendation? That you have to find. There are many companies used clustering for recommendation. You can mention few. Next is, can you name one limitation of k-means? There are many limitations. Think any one of the limitation and comment below. Thank you. That's bring us end of today's lecture. If you have any questions, you can feel free to reach out by the mail ID. Thank you.